This video is on the chain rule, a new method of differentiating, also known then as function of a function. So let's take a wee look at this. Say we have y equals x plus 2 all cubed. The way this sits, we don't know how to differentiate it. The way we know how to differentiate stuff is, say it's y equals x squared minus 6x to the power of 4 plus 2x. We can differentiate that. You differentiate this term, differentiate this term, differentiate this term. And what I've always said to people is it should always be in the form of ax to the power of n before we differentiate it. So here, it's not in that form. So what we would do, we could sit and multiply out our brackets. If you do it squared, we'd end up with this, times it by this, you end up with this. Now it's in the correct form for us to differentiate it. If we differentiate it, we'll get 3x squared plus 12x plus 12, and then the 8 disappears. Looking at this, you can actually factorize it, and then so we can take out a common factor of 3, and then this factorizes as well to give us that. So if you look at that, which is our solution, and that which is our question, you can probably see a wee pattern in there. Let's take a wee look at this next one. Say we have y equals 2x plus 3 all cubed. Again, we could sit and multiply that out. You can take my word for it, that if you sit and multiply it out, you will get 8x cubed plus 36x squared plus 54x plus 27. I expect everyone to be able to do that okay. You differentiate that. We're going to get 24x squared plus 72x plus 54. We can take out a 6 there. Gives us 4x squared plus 12x plus 9. Again, you can take my word for that, but this one factorizes. We would split our middle term. 4 times 9 is 36. Two numbers are multiplied to give 36, and now to give 12 are going to be 6 and 6. But that would go to 6, 2x plus 3 upon 2x plus 3. And that would go to 6, 2x plus 3 all squared. You don't need to do this every time you differentiate it, but just to kind of see. And again, hopefully you see there's a wee bit of a pattern there, and it's a bit different than this one. Up here, we had a 3 which we could bring to the front, take away 1 from the power, that's okay, but things have changed very slightly here, so we need to investigate this. This is all well and good if it's a 3, but if it's a 6, you're going to be here all day multiplying it out. So we're looking for a new method of differentiating. So if you read down below, this again follows the same rule except for a factor of 2 from differentiating inside the brackets. So that we would expect a 3 there, but we've actually got a 6, but that's okay. Chain rule allows us to differentiate functions of this type with relative ease. The rule states this: dy by dx is dy by du times du by dx. And this is the way we're going to set it up. So let's take a wee look at example 1. We're going to let y equal 3x minus 1 to the power of 6. And the way the chain rule works is generally if it's something within a bracket or something to a certain power, we can take this out and let it become a u. This seems a bit strange at first sight, but we're going to let u equal 3x minus 1. That's the wee bit that's in the bracket. If I rearrange this, then I'm going to get y equals u to the power of 6. If I differentiate this now, remember it's always kind of, this would be dy by dx. If we differentiate this, this is going to be dy by du. So dy by du, this is easy for 6u, take away 1 from the power to the power of 5. And here if I differentiate this, I get du by dx. And that's then just going to give us a 3. The chain rule states the following: dy by dx equals dy by du multiplied by du by dx. That you need to learn and know and love. So we're looking for dy by dx. It's asked us to differentiate this. Sorry, you can see it there in the question. So that's dy by dx. Dy by dx. dy by du is 6u to the power of 5. Du by dx is 3. So that's going to be 18u to the power of 5. And we now can change back our u. At the very top of the page, we let u equal 3x minus 1 3x minus 1 all to the power of 5. Hopefully you can see all that there and see where it comes from then. So the wee trick to this, again I shouldn't tell you this quite yet, we're going to do it the slow way the first couple of times so you get your head around it. You take away 1 from the power, that becomes a 5. The 6 moves to the front, but also you need to multiply it by the bracket differentiated. So if you differentiate that bracket there, it's going to give you a 3. So that's the 3 times the 6, and that's where the 18 comes from. Let's look at a few more examples. So we have this one here, and this is a quotient one. Again, we could do it a couple of different ways, but I'm going to rewrite this as y equals 3x minus 1 to the power of minus 1. Again, quite similar to the previous one. I'm going to let u equal 3x minus 1. This is our new way of doing this using the chain rule. Y equals u to the minus 1 because I've let u equal the bracket. And dy by du, again you need to think about that to make sure you're getting it right. Multiply through, so minus u, take away 1 from the power to the power of minus 2. du by dx, differentiating this bit, is going to give me 3. Chain rule states the following: dy by dx, which is what we want, says find dy by dx, is dy by du times du by dx. dy by du is minus u to the minus 2, and then we're going to multiply that by 3. That gives us minus 3u to the minus 2 minus 3x minus 1. So I'm subbing in my u again to the power of minus 2. And here's a bit where plenty of people will make a mistake. This here's the power of minus 2, so we're going to bring it back down to the bottom, because remember that's how we get given it in the question. Remember it was given as a quotient. But the minus 3 doesn't go down, so minus 3 all over 3x minus 1 all to the power of 2, sorry, of 2, apologies. So that's that one. As I said, we did have a quick method for doing this, so let's just then kind of check about our quick method and see if we can make any sense of it. I would not recommend this to start with. I would be practicing the slow way, but here's what it says. You write out the bracket 3x minus 1, differentiate outside the brackets and multiply by the derivative of the expression inside the brackets. So differentiating outside the brackets gives me a 6, and then I change that to a 5, and you multiply by the bracket differentiated. So we differentiate that, then you get a 3. Tidying that up, it gives us 18, 3x minus 1 all to the power of 5. This one will require a little bit more work because we don't have a bracket in here to start with, but let's get our bracket and then we'll see if we can suss it out. So 3x minus 1 all to the power of minus 1 dy by dx. Let's follow our wee rule up here. Differentiate outside the bracket, so pretend this whole bracket's an x, minus 1, 3x minus 1, take away 1 from the power, minus 2, multiply by the bracket differentiated. So we're then going to times that by 3. So how does that tidy up? Minus 3 upon 3x minus 1 all to the power of minus 2. Let's see if we can get it right this time. Minus 3 all over 3x minus 1 all squared. Here's a sort of case where you would see questions like this. So let's see if we can get ourselves a wee answer to this. Example 3, find the gradient of the curve. So that means we're going to have to differentiate y equals ln x squared plus 2 at the point where x equals a half. So a wee bit more going on there. We have y equals ln x squared plus 2, and I'm going to let u equal the bracket. U equals x squared plus 2. That means we have y equals ln u. I hope you remember from the last video, it was the second most important thing I asked you to suss out, and that was then what do you get if you differentiate ln x, and that's 1 over x. So if you differentiate ln u, dy by du is going to give us then 1 over u. Up here we're going to have du by dx, and that's going to give us 2x. We're asked to do the chain rule here, so we weren't asked, but this is the way we do it. dy by dx is dy by du multiplied by du by dx. dy by du is 1 over u multiplied by 2x. That's the same as 1 over, what do we let u equal? X squared plus 2 multiplied by 2x. So our differentiated function then is dy by dx equals 2x over x squared plus 2. Incidentally, this happens all the time for ln functions. The way it comes out, it'll come out as a quotient, and what I mean by that is kind of divide numerator and denominator. And what it is the original function on the bottom, and the top is the differentiate function. If you differentiate the bottom there, you're going to get the top. And that comes in an awful lot of use later on in the year, especially for integration. Doing this backwards, then you would end up with this then kind of as an ln function. Anyway, we're not there yet. We have to find it then whenever x equals a half. So whenever x equals a half, we're going to get 2 upon a half, and then a half squared plus 2. So that's going to be 1 over, right, what are we going to have? You square that, you're going to get a quarter. Add the 2 gives me 2 1/4, which is the same as 9 over 4. 1 over 9 over 4 is then 4 over 9. So that's the gradient of that particular function at that point. Example 4 then, again, we saw this in our last section, differentiating. This is like e to the kx, but let's see how it works out. And that's a good wee example for us. So we have y equals e to the 2x. All the previous examples, we have let u equal what's in the bracket. What often is quite useful as well, we can let u equal the power. So we're going to let u equal 2x. So we have y equals e to the u. dy by dx, the most important thing I asked you to remember from the previous video, differentiate e to the u, we just get e to the u. Du by dx is going to give us a 2. We're asked to find dy by dx. dy by dx equals dy by du times du by dx. dy by du is e to the u, du by dx is 2, that gives us 2e to the u, and that gives us 2e, changing this back then to the 2x. Again, I hope you recognize that rule from previously. If you differentiate e to the 2x, you get 2e to the 2x, and that's then why it works. The general form of that is you're differentiating e to the kx, and it gives you ke to the kx.